Hi, this is Alex from devstories.eu. LiteLLM, the Universal LLM Gateway, episode 20 of 24. OpenAI handles conversation state beautifully, keeping your client code entirely stateless. But locking your architecture into a single provider just to keep that state management is a heavy price to pay. The Assistants API bridge in LiteLLM resolves this tension. The bridge is a feature of the LiteLLM proxy but exposes the exact endpoints of the OpenAI Assistants API. You hit standard paths like the v1 Assistants and v1 Threads endpoints, but you route the actual text generation to any model you want. Standard chat completion interfaces are stateless. Every time you ask a question, your client must send the entire conversation history back to the server. This consumes bandwidth and complicates your client-side code. The Assistants API solves this by keeping the conversation history on the server inside a thread object. You just append new messages to the thread and tell the server to run the assistant. The problem is that most other providers, from local setups to enterprise cloud alternatives, do not offer this stateful interface natively. The LiteLLM bridge polyfills this missing functionality. To make it work, you configure the LiteLLM proxy to connect to a database. This database will act as the storage layer for your conversation state. Then you point your existing OpenAI client to the LiteLLM proxy URL instead of the default OpenAI servers. The logic flow starts with creating an assistant. You send a request to the proxy defining the assistant's instructions and specifying a target model. This could be an Azure OpenAI deployment or an OpenAI-compatible Astra model. The proxy saves this configuration in its database. Next, you create a thread. A thread is simply an empty container stored by the proxy. When a user says something, you send a request to add a message to that specific thread. The proxy saves the message. Up to this point, the underlying large language model has not been contacted at all. Here is the key insight. The bridge only talks to your target model when you trigger a run. When you tell the proxy to run the assistant on a specific thread, LiteLLM retrieves the entire message history from its database. It formats that history into a standard stateless chat completion payload. It then sends that flat payload to the underlying model you configured earlier. The model evaluates the conversation and returns a response to the proxy. LiteLLM takes that text, packages it as a new assistant message, saves it into the thread database, and updates the run status to completed. Your application code remains completely unchanged. It still thinks it is talking to a native stateful system. The proxy handles the translation transparently, taking a stateful client request, executing a stateless model call, and maintaining the persistence layer in between. This separation of concerns means your client architecture can rely on a modern, state-managed API interface while your infrastructure remains entirely free to swap underlying models based on cost, privacy, or performance requirements. Thanks for listening. Happy coding, everyone.